All right, we're going to be dividing complex numbers. Okay. Just remember, this is very important to know that there can be no radicals can be left in the denominator. Now, I'm saying radicals, right? But if you look here, it doesn't look like we have any radicals in the denominator. But we do. Remember, I is equal to the square root of -1. So really, I can take this and rewrite it as 2 minus 7 square root of -1 over 1 plus the square root of -1. See here, we have a radical in the denominator. It's kind of disguised, but you have to remember, I is equal to. All right. Can you see how this looks a lot nicer than with all these radicals and negatives inside of them? All right. That's one of the reasons why a lot of people like to use i's. It makes this mess look a little bit more manageable to work with. All right. So in other words, there can be no radicals, or if you need to remember, say no radicals and I, or imaginary numbers, can be left in the denominator.
Interruption. Leslie Perez is A with her. Bring her to the security desk, first floor. Leslie Perez and our aide, first floor, security desk. Thank you.
All right. If she could not hear that, oh my. All right. Back to the lesson. All right. So that takes us to the next part, the conjugate. Because if you notice, the denominator has more than one term. All right, so in order to get I out of there, or in order to get the radical out of there, when there's more than one term in the denominator, we have to multiply by the conjugate. All right, conjugate means whatever I have, I change it. Well, what's the difference between these two? A is the same, B and B, I and I, but the only thing that's different is this one's positive and this one is negative. So really the difference between these two binomials is that the imaginary part, another one, the part with the I in it, it's opposite. All right? So the imaginary part is opposite. That's what the conjugate deals with. So if I want the conjugate of something, I take the opposite. So in other words, if I have 1 plus I, the conjugate is what? Be 1 minus I. Right? Just the imaginary part changes signs. That's all it does. It changes signs. All right. So now when we're rationalizing, so we're going to be rationalizing the denominator with complex numbers. To rationalize it down with complex numbers, you have to multiply, right, the top and bottom by the conjugate. Instead of multiplying the top and bottom by just the radical, since I have more than one term, I got to multiply by the conjugate now. The top and bottom by the conjugate. And what will happen is when you multiply the thing out, there'll be no more i's or no more radicals in the denominator. Okay? So let's go ahead and take this one and finish it. So we have 2 minus 7i over 1 plus I. The conjugate is 1 minus I. So I must multiply the top and bottom by the same thing. All right, since I'm multiplying, put everything in parentheses. And just like in the last video, you're multiplying, so we have FOIL, so you just do the top. So 2 times 1 is 2. 2 times negative I is negative 2i. Negative 7i times 1 is negative 7i. And negative 7i times negative I is positive 7i squared. Bottom, 1 times 1 is 1. 1 times negative I is negative I times 1 is positive I. And positive I times negative I is negative I squared. Well, remember I squared is negative 1, so this right here becomes a negative 1, and this becomes a negative 1. So I have 2 minus 2i minus 7i minus 7 over 1. If you notice here, negative I, they're opposite, so they cancel out. It goes to 0, so you're left with 1 minus a negative 1. And look here. I'm not even finished with the problem yet, and I've just now noticed there's no more i's or radicals in my denominator. So that means I'm doing something right. So now I'm just going to do is just finish combining like terms, and then we should be good to go. So the top, these two terms are like terms, so that gives me negative 5. These are like terms, so that gives me negative 9i over 1 minus, so that becomes 1 plus 1, which is 2. And I am done. All right. We just did that. All right, let's do the next one. 3 plus 11i over negative 1 minus 2i. Right here, that means I have to rationalize using the conjugate. All right, so the conjugate, I multiply the top and bottom. So the a part stays the same, b part is opposite. So this is a negative, becomes a positive. Okay, so now we use FOIL. So 3 times negative 1 is negative 3. 3 times 2i, 6i. 11i times negative 1. 11i times 2i is positive 22i squared. And remember, I squared becomes a negative 1. So that becomes negative 3 plus 6i minus 11i minus 22. All right, let's do the bottom. Negative 1 times negative 1 is 1. Then negative 1 times 2i, negative 2i. Negative 2i times negative 1 is positive 2i. And negative times a positive is negative 4i squared. That becomes a negative 1. Notice here we get 1. Those cancel to 0. Negative 4 times negative 1 is positive 4. I is gone, so we're on the right track. So top in like terms is negative 3 and negative 22 is negative 25. Positive 6 and the negative 11i, so that becomes a negative 5i over 5. Now, if you leave it like this, you will lose a point because you can simplify more. Just look at all 3 parts. They're all divisible by what? They're all divisible by 5. So I'm going to divide each of those. So now we're simplifying a fraction. Right? That's what we're doing. So negative 25 divided by 5 is negative 5. Negative 5 divided by 5 is negative 1, so it's negative I. 5 divided by 5 is 1. So that, or you can just leave it as negative 5 minus I. So it even simplifies down even nicer. All right, last one. All right, so I want you to hit play. I'm just going to play. Duh. Hit pause, try it, simplify it, and then hit play, and then you can compare notes while I'm doing it. And so you make the corrections if you need to. All right, so multiply by the conjugate. Right, because remember, these stays the same, these are opposite. So once I have this, I do with the top as well. All right, so now it becomes multiplication. So 3 times 1 is 3. 3 times negative I is negative 3i. Negative 4i times 1 is negative 4i. And negative 4i times negative I is positive 4i squared. Remember, I squared becomes a negative 1. So I have 3 minus 3i minus 4i minus 4, because positive 4 times negative 1 is negative 4. All right, let's do the denominator. So 1 times 1 is 1. Negative I, positive I, and then negative I squared. Okay. So 1, that goes to 0. I have this right here is negative 1. So minus negative 1 becomes plus 1. Notice that the i's are gone, so that's good. So 3 minus 4 is negative 1. Negative 3i, negative 4i is negative 7i. 1 plus 1 is 2. If you look at all three parts, 1, 7, 2, none of them are divisible by anything, so therefore we are finished. If you have any questions on this video on dividing, on any questions or any examples, just shoot me an email through my community or on YouTube. Leave a comment, leave an example or a problem that you don't understand, and I'll get right back to you.